All right, so we've explored the Pythagorean relationship. Now we are going to apply the Pythagorean relationship in terms of more use of algebra as opposed to the geometry of the actual volume, or sorry, area of the squares. So if you can recall, the Pythagorean relationship is basically the areas of the squares of the legs, the areas that we added together, totals the square on the hypotenuse. So it equals the sum. So if you add them together, the sum is the area of the hypotenuse. But there's an easier way to do this rather than just going and drawing squares all the time, because now you understand that relationship. Now let's look a little further. So we looked at this last time. This can be translated into a formula, and the formula is a squared plus b squared is equal to c squared. And remember that c is always kind of a special letter used to denote the hypotenuse. Okay, so that one is reserved for the hypotenuse. So the formula is a squared plus b squared is equal to c squared. And this is the Pythagorean formula. Okay, so let's work through some examples here. Finding the length of the hypotenuse. This time, we are not going to draw the squares on each side because that can be quite time consuming. But we are going to look at the area. We are going to think of the area that we're doing of each square built off the legs. So A and B, it doesn't matter which leg they are. You can just pick a leg for A, pick a leg for B, as long as you're not picking a leg for C, because C is the hypotenuse. So we're going to pick a leg for A. Let's just use 12. So we have 12 squared plus 5 squared, and that's going to be equal to, now this time I don't know what my C squared is, but we'll figure this out here. And what we want is we want the length of the hypotenuse, not the area. So we're going to find the area, but then we're going to have to kind of do one more step to find the actual side length. So 12 squared is 144. 5 squared is 25. I add these values together, is 169. Now, remember, this is the area. We added the two areas together. This is the area of that square built off the hypotenuse. In order to find the side length, we have to actually find the square root, right? Or the two numbers that multiply to equal 169. So to find the side length, what we do is we take the square root of 169, and this will be the side length, which is actually going to be 13 centimeters. Not centimeters squared, because I'm actually just finding the side length. So hopefully that one makes sense. You can go back and watch that one again, but we're going to do another example very similar to the one we just did. So this time I have a right triangle here. I should have drawn in the right angle there with the square. Again, A and B doesn't matter what they are, so let's make A 2. So 2 squared plus 3 squared should be equal to my C squared. 2 squared, of course, is 4. 3 squared is 9. And that is equal to my, sorry, I just add them together. So 4 plus 9 is 13. And remember, this is the area of that square. This time we're going to take the square root of 13. Remember, we did some estimation, but this time I want you to be very accurate. So we're going to actually use our calculator. There's no real other way to do this. So use your calculator and you figure out exactly what it is. It's best to round to at least one decimal place. Don't get rid of the decimal, but round to one decimal place. So this is actually equal to 3.6. And the units are millimeters. Okay, so the side length of the hypotenuse, that's this side here, is equal to 3.6 millimeters. What we should probably do is say that C is equal to this, and C is equal to that, because that's what we're finding, the hypotenuse. Okay, so we found the length of the hypotenuse. Now we're going to find the length of each leg, of a leg. This time it's a little bit different. So remember that the hypotenuse is always the longest side, and is also right across from the right angle. So if you pretend you're standing at the right angle, and I'm looking across from the right angle, that will show me exactly where the hypotenuse is. Okay, so just be aware of that. So then that value, that 17 centimeters in this case, will be the value for C not the value for the leg, right? So, okay, let's put the 8 into either A or B. Let's just use A. So 8 squared plus B squared is equal to 17 squared. 8 squared I know is 64, plus B squared we don't know, so we're going to do a little bit of algebra. And 17 squared is 289. So what I actually have to do here, in order to solve for B squared, or B eventually, the area of the square, is I have to get rid of this 64 by subtracting by 64 on both sides. Okay, whatever you do to one side of the equation, you have to do to the other side. So when I subtract 64 from 289 minus 64, I end up with 225. So on the left-hand side, it's gone. I'm left with just B squared, which is this side over here. We're going to find the length of it again, which is equal to, what did we say? 225. And remember, the B squared is the area of the square. I want just the side length, so what I have to do is I have to take the square root of that 225 in order to find just the side length of B. We just want the side length, so I don't want B squared, which is the area. And if I take the square root of 225, I end up getting 15, and this is in centimeters. So there's one extra step when you're finding the length of a leg you have to subtract, because you're given the value for C. You're given the hypotenuse. You're given that area, or the side length, I mean. Okay, so let's do one more example over here. So where's the hypotenuse? Oh yeah, right across from the right angle. You can even put an H if you want to by the hypotenuse. Find it right away. Pretend you're standing at the right angle, look straight across, and that longest side is the hypotenuse. So that will be my C. The other side, and you can just be very consistent if you want. You can always just put the other side, the leg, in A. So I have 4 squared, whoops. 4 squared plus B squared is equal to 9 squared. 4 squared is 16 plus B squared is equal to 81. Next step, I have to get rid of the 16, so I do a little bit of algebra. I subtract both sides, subtract 16 on both sides. So on the left-hand side, it's gone. 81 minus 16. Again, if you can't do it in your head, don't worry about using a calculator. It's okay. So B squared is equal to 65. This time it doesn't work out evenly because we want the side length. Remember, that's the area of the square. So the side length, the square root of 65, is 8.06. Now, in this case, I would probably round to 2 decimal places, just because I know I teach math 10, 11, 12, and the more accurate, the better. So I'm going to round to 2 decimal places this time because then we're really accurate, which is 8.06. Right? Because the number next to it is a 2, it makes the 6 stay the same. So 8.06. So B is equal to 8.06, and this time it's in meters. So that's how you find the length of a leg as opposed to the length of the hypotenuse. The length of the leg, again, there's one extra step you have to do. You have to do that subtraction. One last example here. How far does Mr. Howell have to run across this yard? This is a pretty, I don't know if it's a big yard, it's pretty small. I mean, to find out the number of feet, you multiply these by 3, so it's like 30 feet by roughly, well, it's 3.2. 57.6 feet, I guess it's kind of far. It's not that far. But anyway, if you want to run across the yard, you're going to run across right from one side all the way to the other, okay? So we're not going to go around, we're going to go straight across because the shortest distance between 2 points is a straight line. So you're not going to go 18 and then 10. We're actually going to see how much less distance it is. So we're going to use Pythagorean theorem. A squared plus B squared equals C squared. The right angle for this rectangle would be here. The hypotenuse would be right across from it, which would be right there. I'm just going to use my little h for my hypotenuse. And then I just plug the 2 legs into this equation. So the 2 legs are 10 and 18, and that will be equal to C squared. Again, my hypotenuse. 10 squared, of course, is 100. 18 squared, you may not have memorized. And notice on the calculator, I have this little squared button. Makes things a lot easier. So if you didn't have it, If you didn't want to go 18 times 18, you can just hit that. And on your handheld calculator, you'll have the same thing. And that's 324. That's equal to c squared. Again, we want how far, so the distance, not the area of the square. So 100 plus 324 is 424, which is equal to the area of the square built off the hypotenuse. And we want the side length, so we want the square root of 424. Take the square root, and we get 20 point, this time I can round to 1, so 20.6, because the number next to the 5 is a 9, so that bumps the 5 up to a 6, so 20.6. And this is in meters. Now, if we see 20.6 meters, that's a lot less than going all the way around the side, because that would be 18 plus 10, which would be 28 meters, right? I know it's only a distance of 8 meters, but that's roughly like, you multiply by 3. So 8 times 3 is 24, plus a bit more, say 25 or 26 meters, or 26 feet, which is still quite a significant amount. So to go straight across from one point to the other, it would be 20.6 meters. Hopefully that helps you go through this section. If you have any questions, let me know. You can go back and rewatch the video or pause it. Remember to take notes, write all the stuff down, and let me know if you have any questions.